Hello students, welcome to the 8th episode of our example problem series for Circuits 1 here at NDSU. In this episode, we are going to cover mesh current, which, like node voltage, is a very important circuit analysis technique that can make very complicated circuits easy to solve. Let's jump right in. Here we have a 10-volt source in series with a 15 ohm resistor in parallel with a 10 ohm, a 5 ohm, and another 5 volt source. Okay, the first step of any mesh current analysis is to draw our meshes. What is a mesh? It's a closed loop around our circuit or a part of our circuit. I see two of them in this circuit that I think will serve quite nicely. One there and one there. Let's call it I1 and I2. Notice the directions of these meshes that I drew. That comes in handy later. What we need to do is basically do a Kirchhoff's voltage law around these two loops and solve for expressions for I1 and I2. So let's do that. KVL at, or around, more or less, I1. Let's start right here. Let's make that very clear. All right, we got going this way. Let's make sure we follow the direction of the mesh that we drew. Negative 10 volts plus 15 and the current through that 15 ohm resistor, which is just I1, plus, now here's where it gets a little bit tricky, 10 ohms times the current through that 10 ohm resistor. Well, with what we have drawn here, we have I1 going down through that 10 ohm resistor, but I2 going up through the 10 ohm resistor. So we need a difference of I1 and I2. That's very important. Set it all equal to 0, and let's solve everything out. So we're going to get 15 I1 plus 10 I1 minus 10 I2. Sorry about that. Getting a little lost. Okay, let's just make this simplified. 25 I1 minus 10 I2 equals 10. Let's divide by 10. 2.5 I1 minus I2 equals 1. All right, awesome. Let's do it again for I2. KVL at I2. Let's make that a little better. I2. Okay, let's start right here. And remember to go in the direction that we have I2 labeled. So the first thing that we're going to meet is that 10 ohm resistor. However, we're solving for I2, so let's take the difference between I2 and I1 this time. I2 minus I1 plus 5 I2, just the current going through that 5 ohm resistor. And then we reach the 5 volt source, 5 volts, equal to 0. I'm kind of running out of room, so I'm just going to skip to the simplified version of this equation. It's going to be 3 I1 minus 2 I1 equal to negative 1. Awesome. We have two equations, two unknowns. Let's just go through and solve it. We're going to use this equation and just solve for I2, which is going to give us, let's see, 2.5 I1 minus 1 is equal to I2. Let's substitute this into this equation. That's going to give us 3 times 2.5 I1 minus 1 minus 2 I1 equal to negative 1. Solving through here, we're going to end up with, what, 7.5 I1 minus 3 minus 2 I1 equals negative 1. Ugh, need to be more careful. It's an equal sign. That is going to give us, in the end, I1 equal to roughly 363 milliamps. Let's substitute I1 back into this equation. I2 is then going to be negative 90.91 milliamps. Okay, we got a negative number. We got a negative current. What does that mean? It's rather simple. The way that we have I2 labeled is not the actual direction in which I2 is flowing. It's actually going in the opposite direction. That's all that means. Now, instead of doing all this substitution of these equations, you could easily put it into a matrix form and just do some linear algebra to solve for I1 and I2. That's perfectly fine. In fact, I encourage it because circuits that you're going to encounter are going to get a lot more complicated, and that is far, far easier to solve for, let's say, 4 equations, 4 unknowns. However, since we just had 2, this was fairly easy to do, and we come out with these 2 values for our current. That's really all that mesh current is. It's fairly straightforward, but it does take a little bit of practice to master. Thank you for watching.